Welcome students. Welcome to the third lecture of module 2, that is pumps and actuator under this fluid power systems. And the topics which we are going to cover in here is lobe pump, gerotor and screw pumps. In the last class we have discussed regarding the pump theory and the gear pumps. So only two types of gear pumps we have discussed. Now we are considering the lobe pump, gerotor and screw pump for the further explanation. My name is Veeresh Kumar KS. Let's start the class. So first we see this lobe pump. So what is this lobe pump? Actually, if you see this, whatever the lobe pump, it will be look like a external gear pump. Okay. Instead of gears, instead of two gears, we are using the two lobes. Okay. This is the lobes which are extended in here. The shapes which are shown at here, this called as a lobe. So there are three lobes in each whatever the shaft. Similarly, three lobes in here also. So what happens in this type of whatever the pumps, we have the rotation, whatever the prime movers which are going to providing the rotation for the both lobes. Okay, so for the both shaft only the whatever the rotation is going to be provided at here. So there is no meshing is going to take place. So because of the meshing, the whatever the primary gear and whatever the driven gear, which not it is not like that. The both whatever the lobes are rotated by its own whatever the shafts, which is connected to the prime movers. The action of this whatever the lobe pump is similar to the external gear pump. What happens? These lobes when unmeshes, and this lobes when it moves here, it will tends to unmesh. So what happens? It will increases the volume at here. Okay, when the volume is increased at here, it will be causing the vacuum. Okay, it will be causing a partial vacuum. Because of this partial vacuum, the whatever the liquid which is in the reservoir will be sucked inside this whatever the portion. So this sucking of liquid will be collected at here, and it will be carried through this whatever the lobes, and through, between this lobe and this whatever the periphery of this casing, and it will be transmitted at here. And when these lobes, when it is going to again engage it with each other, it will pressurizes the fluid at here, and the volume reduces at here, and because of that the liquid is going to be pushed outside. As the volume reduces, the liquid experience the higher pressure, and it will be pushed outside for the next process. Like that, this whatever the lobe pumps are going to be working at here. Okay. So you can see the lobe pump stages in here. This is just an animation. You can see just a diagram. So the liquid enters at here. Okay. First the liquid enters. The lobe pumps collect at this portion. Then liquid, whatever the lobes will rotate in opposite direction. Because of the rotation, the liquid is going to be transmitted around this periphery of casing, and it will be pushed at this portion with a higher pressure, and it will be transmitted. So this is the stages. First stage, second stage, third stage. First stage, it is the intake stage. Second stage, it is going to be transmitting stage, and third stage is the discharge stage. Like that, whatever the transmission of liquid is going to takes place. So you can see the video in here where the lobes are rotating. Because of the rotation, the liquid is going to be collected at here, and it will be transmitted at here. Okay. As you see, there are parts which are seeing in here is very less. Okay. So in the gears we have huge gear teeth. Number of teeth are more, but in here only three whatever the lobes which are present. Because of that, the higher volume of fluid is going to be transmitted. Higher amount of fluid is going to be transmitted, and the pulsation, you can see the pulsation in here. The pulsation is also high in this type of whatever the lobe pumps. Okay, like that this will be considered. One of the advantage of this lobe pump, we can consider any impurities. Okay, since the impurities may not disturb in here, you can see the lot of contaminants were present, but it is not disturbing this whatever the lobes. So it is one of the advantage of this type of lobe pump. Okay, so like that, the pump is going to be transmitted to the next stage. Okay. So what are the advantages of this lobe pump? Lobe pump can handle solid, slurry, paste and many liquids. So that is one of the advantage of lobe pump. Because of higher volume of whatever the transmitting ability, It can handle the solid, means if the liquid contains some solids, it can also easily transmit. If it contains slurry, it can be transmitted, and many liquids, it can transmit many liquids. No metal to metal contact takes place. So as in the gear pumps, the meshing is going to take place, but in here there is no contact between metal to metal. Even the lobes are not going to contact each other, and this lobes are not going to contact with the casing also. Like that, it is having the no metal contact, metal to metal contact. Superior cleaning in place and sterilization in place capability. So what happens? Cleaning in place is nothing but it is having the ability to clean itself because the volume is more, so it can easily clean up that whatever the liquid. And sterilization, it can also make the sterilization of that whatever the place. So if it is having any solid particles, contaminants, it can easily remove it. So long term dry run. So it is having the ability to run dryly, means if there is no liquid, and only the dry run is going to be considered. So it is not going to have any problems, because in the gears, if the dry run is considered, the meshing action will leads to wearing of that whatever the gear tooth. But in here there is no metal to metal contact, so that's why it can work for the long term dry run. So that is one of the advantage with lubrication to seals. So we have to require this lubrication for the seals, so that it can operate easily in the dry run also. So what are the applications of lobe pump? Lobe pumps are maximally used in polymer industries, paper coating industries, paint industries, pharmaceutical industries, and food industries. There are a lot of applications of this. What are the lobe pump? So lobe pump having different types. Okay, types means the shape. You can see here there are only two lobes which are present at each shaft. Okay, the lobes are only two. In here there are three lobes. In here you can see that four lobes. In here you can see the different shape of lobe. So like that, this shape is also one of different shapes of the lobe pump. Also you are going to consider in here. So next is the Gerotor pump. So what is this Gerotor pump? Gerotor pump is similar to the internal gear pumps. What happens? You have seen the internal gear pump where one is per gear, external gear which is present at the inside of that pump, and whatever the one ring gear which is outside, means it is present like that in the internal gear pumps. Similarly, in here you can also find similar construction, but in here at the center, okay, you can find the whatever the gerotor element. This is the gerotor element, okay, and this is the female gear or outer ring gear. Okay, so it is a gerotor material and it is the outer female gear, and you can see some eccentricity. So it is not exactly at the same center, it is at eccentricity E. Okay, observe in here. So what happens? This is the inlet. Sorry, in here it is the inlet, and this is the discharge port. This is the case which is covering that whatever the gears. So what happens? Similar action takes place in here, as the gear inside gear is connected to the prime mover, this gerotor, and it will rotate with respect to the rotation of prime mover. As it rotates, it will tends to mesh with this whatever the female gear. When it is going to make the meshing, when it is going to meshing, in here first it is going to unmesh. When it is going to unmeshes it here, it will create a partial vacuum. Because of that partial vacuum, whatever the liquid is present in the reservoir, it will be sucked inside and it will be collected here. First initially it is in the low pressure. So when it is and it is going to be transmitted between these gaps. Okay, this gerotor is going to transmit the liquid within the gaps of this internal gear and the external gear, and it will be transmitted to the this unit, that is the output unit. And in here the gear again meshes. In here it unmeshes. In here it is going to mesh. So because of the meshing, the volume reduces at here, and it will create higher pressure. Because of the reduction in volume, the pressure is going to be increases in the fluid, and it will push it to the next unit. So like that, this whatever the Gerotor pump is going to work. And one of the important consideration in here is the gears which are considered in the Gerotor, which is one number is less compared to the female gear. If the female gear having 10 number of gears, then the gerotor having 9 numbers. So if you like that, this whatever the gerotor arrangements are made in here. Okay. Okay, you can see the working in here as the gerotor is rotating at the center with some eccentricity with respect to the outer gear, and it was making the rotation of this whatever the outer ring gear also. So in here it is the inlet, it is the outlet. The liquid is collected at here because of this whatever the unmeshing of the two gears, and it will increases the volume at here because of the increase in volume, partial vacuum created, and this liquid is going to be sucked inside, and then the liquid is transmitted through this whatever the gaps provided, and it will be at this portion the gears again meshes, because of that volume reduces and it will pressurize the liquid to move outside. So like that the working is going to take place in the Gerotor pump. So what are the advantages? Gear pumps are self-priming in nature. So self-priming is nothing but removing the whatever the air particles, air which is trapped inside the pump. So it is having self-priming means it is able to remove that efficiently remove that air particles from the casing. Have lower speed which makes the smoother and less disruptive to media. So it is having lower speed, and because of that it can have the smoother operation, and it will not disrupt to the whatever the system. The output of a gear pump is also more controllable and simple to understand. Output is very controllable and it is very simple to understand as it is in the internal gear pump. Essentially, if you double the speed, you double the output, and this output is independent of discharge pressure. So what happens if you are going to increase the speed, if you double the speed, simultaneously the output is also going to be doubled, and this output is independent of discharge pressure. So pressure is not going to be increases, only the speed is going to increases, speed doubles, and means whatever the liquid is going to be discharged in a higher speed and with the same pressure. So like that it's going to be achieved in this type of gerotor. It is however possible to manufacture gear pumps with a very high discharge pressure with a right configuration. It is possible in this type of gerotor pumps by a high discharge pressure and a right configuration. Gear pumps are better at handling viscous fluids in comparison to the centrifugal counterparts. So it is having the ability to handle the viscous fluids, means it can transmit the viscous type of fluids to one point to the another point. Let's see the application. So applications of this whatever the Gerotor pump is nothing but light fuel oils. Means pumping of light fuel oils can be pumped in here. Lube oil, next cooking oils and hydraulic fluids. So this type of oils can be wherever this oils are going to be used, then you can use this Gerotor pump in the type of applications. Next, we will see the last type of whatever the gear pump in here. This is the screw pumps. Okay, we will see the first construction in here. We will find the two screws. Okay, the two screws which are with respect to its center, which is connected to the shafts. There are two shafts which is having the two screws, and this is the pump body. This is the inlet. This is the outlet. Okay, so what happens? This is connected to the prime mover. One screw is connected to the prime mover, the shaft, and this shaft, when it is rotates, it will rotate this gear, the first gear, not gear, it is a screw, first screw. So when the first screw rotates, it intends to rotate the second screw in opposite direction. These two screws is going to rotate in opposite direction. Because of this rotation of these screws, it will make some partial vacuum at here. Okay, a partial vacuum is going to be considered. So what happens? Partial vacuum will make this whatever the liquid which is in the reservoir to move at here, and it will be transmitted through this whatever the helical gaps which are present in the whatever the screw, and it is going to be transmitted to the this portion. As the liquid is going to be transmitted, so that liquid is going to be collected at here and it will be pushed to the outlet because of the higher volume of liquid collected, and it will be pushed to the next level. So like that this screw pump is going to be working. You can see the similar video in here. So what happens, the inlet port, the liquid is coming in here, and the whatever the gears, this is the driver gear, this is the driver screw, and this is the driven screw. As it rotates, it will be collected in this whatever the screw, the helical gaps, and it is going to be transmitted, and it will be collected at this portion, and as the liquid collected higher at here, and it will be pressurizes that liquid, and it will be transmitted to the output. So like that, this whatever the working takes place in the screw pumps. We will see the advantages of screw pump. Wide range of flows and pressures. So we can expect the wide range of flows and pressure. Okay. So by rotating, by increasing the flow, the amount of liquid which is going to be inside, whatever the collected inside the pump, that may leads to very wide range of flows. Okay, you can change the flow amount of flow, and you can also change the pressure. As the flow changes, pressure also going to be changes. Wide range of liquids and viscosities. I can use the many types of liquids which having the different types of liquid viscosity. Built-in variable capacity. So it is having the built-in variable capacity. Just by amount of liquid, amount of speed variation, you can make the you can change its capability. High speed capability for freedom of driver selection. Means if you increase the speed, it is also possible in this type of screw pumps. Low internal velocities. Means you can also expect the velocity, internal velocity can be reduced, and it can be changed the whatever the amount of flow. Self priming with a good suction characteristics. Self priming is nothing but removal of air particles, so it is having good property of self priming, and good suction characteristics. So because of self priming, it can create the vacuum. By that, the suction characteristics is going to be improved. High tolerance for entrained air and other gases. Okay, it is having high tolerance for entrained air and other gases. If you have using the gases air, it is having a high tolerance for those type of gases, which will not affected by that type of gases while it is operating. So what are these applications? The applications are it is used in fuel injection, oil burners, and boosting the hydraulics fuel lubrication circulating. It is going to boost the lubrication property in circulation to pump the high viscous fluids. So these are the applications of this whatever the screw pumps. Okay, thank you, students. I hope you have got the brief knowledge of whatever the different types of gear pump, that is external gear pump, internal gear pump, Gerotor pump, then Lobe pump, and screw pump. Okay, these are the 5 types in this whatever the gear pumps. If you have any doubts, you can contact or you can give a comment in here. Okay, thank you. We'll see in the next lecture.